Alrighty, this is Trig Lecture 125, 126. It's actually, this isn't trigonometry, this is stuff that we should have covered last year, but the pandemic came in and we didn't have school for a while, and this is one of the topics we didn't cover, so I'm backing up and we're going to cover it. It's arithmetic sequences and series, and the student will determine whether a given sequence is arithmetic. Now, I need to talk about the definition of the word sequence real quick. A sequence is just a row of numbers with commas in between them, and there's a distinct pattern to them. An arithmetic sequence, we'll talk about that here in just a second. That's what our topic is going to be today. First of all, let me see if my board is responding. It is, yay! Okay, so what we're going to try to do with an arithmetic sequence is find the common difference, which I'll define for you, write the sequence as an explicit formula, and then find the value of any given term in the sequence. So let's talk about what that means and take a look at a sequence. Here's a sequence, as I said, it's just a bunch of numbers that have commas in between them, and this dot, dot, dot means that this pattern goes on forever. Now, to check to see if a sequence is arithmetic, what we first have to keep in mind is that these are all considered to be terms of the sequence, and we label them, or you'll see them labeled, as a sub 1, a sub 2, a sub 3. These are the first term, second term, third term, fourth term in the sequence, so forth and so on. Somewhere way out here is a sub n. Don't know what term it is, but it's out there a ways. And a lot of times we consider a sub 1 if it's a finite sequence, or if we're looking for a finite sequence, a sub n will be the last term in the sequence. Sometimes they're finite, sometimes they're infinite. So let's take a look what we're best with here. If it's arithmetic, we're going to find a sub 37. That's the 37th term. First thing we want to know is if it's arithmetic. To determine if a sequence is arithmetic, what we do is we take a sub 2, the second term, and from it we subtract a sub 1. So we get negative 16 minus negative 25. Well, that's a double negative right there. 25, this is now positive. 25 minus 16 is 9, if I'm not mistaken. Oops, my board seems to have frozen. There we go. So this difference is 9. Negative 7, we start with a sub 3 and we subtract a sub 2, and we get negative 7 minus negative 16. That gives me positive 16 minus 7, which is also 9. And we get 2, go to a sub 4, subtract a sub 3, 2 minus negative 7. This is now a double negative, so it makes that 7 positive, and 2 plus 7 is 9. And we see that we have the same difference between each consecutive pair of terms. And that's the definition of an arithmetic sequence. It's a sequence of numbers in which consecutive terms have a constant difference. In each case, the terms that are right next to each other, if you take the one on the right and subtract the one on the left, one on the right, subtract, you'll get a constant number. It'll be a common difference. Okay, so we determined that it was arithmetic. Yes, it is, because it has a constant difference or a common difference. And we want to know what is the common difference. Well, the common difference is 9. So we would say this. We use the letter D for difference. D equals 9 in this case. And then it says, well, what is the explicit formula? And here is what we call the general case of the explicit formula. I'm going to get rid of this scratch work here. Here's our explicit case, a sub n is equal to, that's the nth term of the sequence, a sub 1, that's the first term of the sequence, plus n minus 1 times the quantity d. That's the number of terms, or the number of the term we're looking for. So let's take a look at what we've got here. If I were going to try to find the explicit formula, I need the first term, which is negative 25, plus Don't know how many terms there are, but I do know the common difference. I would then open these. A sub n is equal to negative 25. I would use the distributive property plus 9n minus 9. I just distributed that. And then I would combine these like terms. And that would give me a sub n is equal to negative 34 plus 9n. Now, a lot of times I would put the 9n first and the negative 34 second, but the worksheet that you guys are going to be doing today lists the constant first and the variable term second, so that's how I'm going to leave it. Normally I put 9n minus 34. But here's what we'd be looking for. That is the explicit formula that you'll be asked for on today's worksheet. Let's see if I can move it over here. No. Okay, so we found the explicit formula, and now we want to find the 37th term in the sequence. So I would say a sub 37 is equal to negative 34 plus 9 times 37. We're going to look for, here's our explicit formula again, a sub n is equal to negative 34 plus 9n. I'm going to scroll this up so I don't have to lean over like that. Now I'm looking for now the 37th term in the sequence. Well, I could just keep adding 9 until I hit 37 terms and then see what the sequence is. But if I have the explicit form, I can just say, well, if I'm looking for the 37th term, that'll be negative 34 plus 9 times 37. Looking for the 37th term is plug in 37 into the explicit form, then we let our calculator do the walking. And we hope I haven't made any mistakes. There we go. 299. So the 37th term would be 299, providing I haven't made any mistakes. And I think I've got the key over here somewhere. Let me see if I can find it. Oh. Ah, here it is. Maybe. 299, yay. Okay, so that's what we're doing today. We determined that it was arithmetic because it had a common difference. We were asked to find the common difference, so we stated it. D is 9. And then we were asked to find the explicit formula, so we used the general case, plugged in specifics, the first term and the common difference, distributed the common difference, combined like terms, and then we're looking at our explicit form of the equation. Then to find any term, the nth term, the 50th term, the 100th term, whatever term you're looking for, you just plug it into the explicit formula, and if you do your arithmetic correctly, that will give you your answer. The 37th term in this sequence, if we keep adding 9, the 37th term will be 299. Now let's take a look at another one. I'm going to say 4 minus negative 2. I'm asking myself, is this arithmetic? If it is, I'm going to find the 51st term. So 4 minus negative 2 is 6. Got negative 8 minus 4. That's negative 12. I'm going to stop right there. These differences are not common. They're not the same number, so it's not arithmetic. So if I were taking a multiple choice, I would look for a multiple. If I was working a multiple choice worksheet, I would look for this among the choices. This looks like the word arithmetic, but it's arithmetic. It's an adjective instead of a noun. Arithmetic is a noun, arithmetic is an adjective, and this is an arithmetic. This is not an arithmetic sequence. This is an arithmetic sequence because it has a common difference. Okay, so we're done with this one. It's not arithmetic. Let's take a look at another one here. The last one. Negative 33. We're going to check to see if it is arithmetic. This is positive 40 minus 33, what is that, 7? I think. And then we got negative 26 minus negative 33. That's 33 minus 26, that's also 7, if I haven't made a mistake. And negative 19 minus negative 26. So that's positive 26, 26 minus 19 is also 7. So this is arithmetic. Now in a multiple choice it won't say yes, but it'll just go ahead and you'll look for the common difference in the explicit formula and the 31st term that matches what we find. Okay, if it's not arithmetic, we can't do any of this. Okay, so our common difference is 7. D equals 7. D stands for common difference. That kind of makes sense. And now we're going to find our explicit formula. I'll get rid of my scratch work here. Now I have A sub n is equal to A sub 1 plus the quantity n minus 1 times d. And I'm going to plug in everything that I know, simplify the equation, and then look for the 31st term. So here we go. A sub n is the nth term. Don't know that one. I do know the first term is negative 40 plus n minus 1. Don't know n. Don't know how many terms there are, but I do know d is the common difference, which is 7. Now I'm going to open this set of parentheses using the distributive property and combine like terms just to simplify it a little bit. A sub n is equal to negative 40 plus 7n minus 7. That's what I get if I distribute this. These two terms right here will combine, and that will give me A sub n is equal to negative 47 plus 7n. And notice again that I put the constant first simply because that's the way on your worksheet your answers are going to be listed that way. I personally usually put the variable term first followed by the constant because it's linear, and you can therefore the normal linear term is y equals mx plus b, and you can see the slope and the y-intercept more easily. It's just because I like it, put it that way. Alrighty, left it like this. That's the explicit formula I was looking for, and so I found that. And now I want to find the 31st term. So the 31st term, let me scroll this down a little bit. There we go. Looking for the 31st term. Oops, it's not going to work. Looking for the 31st term, hopefully I won't make a mistake. Negative 47 plus 7 times 31. And that will tell me, if I do my arithmetic correctly, if I keep adding 7 until I get 31 terms, the 31st term will be whatever I get here. So let's see what that'll be. 7 times 31. I'm going to subtract 47 from that. 170 if I haven't made any mistakes. And you guys know me well enough to know that I make mistakes. So we'll check to see if this is right. Let me see, I got a key around here somewhere. 170, yay! So I didn't make any mistakes. And that's it in a nutshell, arithmetic sequences. That's how we're going to be dealing with them to start with on the worksheet. You can do this.